Hello students, this is Shachi Tannan. Welcome to my channel Crack Chemistry. Today I am going to discuss a class 8 topic. The name of the topic is Chemical Effects of Electric Current Part 4. In today's session, I will discuss the numerical part. I'll tell you some very simple and interesting tricks to solve the numericals based on this topic. Students, for part 1 to part 3 of this chapter, please check the I button. Before starting, I want to remind you to subscribe my channel for getting information about further important uploads. And don't forget to like and share this video with your friends. So come with me and let's crack chemistry. Topic is chemical effect of electric current. Before starting the numerical part, first we will discuss some of the general terms. On the basis of current carrying capacity, all the materials have been divided into 3 categories. The first category is conductors. Conductors are those materials which allow current to pass through them. For example, metals, graphite, alloys, etc. Then the second category is semiconductors. Semiconductors are those materials which have conductivity between metals and non-metals. Examples are metalloids like boron, silicon, etc. Metalloids are also called as semi-metals. And the third category is insulators. Insulators are those materials which do not allow current to pass through them. For example, wood, plastic, etc. Now we will see what is current. Current is flow of electrons or charge per unit time, or we can write I is equal to Q by T. Or we can say Q is equal to I into T. Unit of current is Ampere. Which is written as A. Now we will see what is Ampere. Students, just now we have seen that I is equal to Q by T, where Q is charge and unit of charge is Coulomb, and T is the time. The unit of time is second. So we can write here I is equal to C by S. C is Coulomb, which is the unit of charge, and S is the second, which is the unit of time. So we can say that the current is said to be 1 ampere if 1 coulomb charge flows in 1 second. Now we will see how to calculate the charge. Charge is equal to number of electrons into charge on 1 electron. We can write number of electrons as N, charge on 1 electron as E. So we will get the formula Q is equal to N into E. Value of E is equal to 1.6 into 10 to the power minus 19 coulomb, which is charge on 1 electron. Now we will discuss all the formula we will use for solving the numericals. So first formula we have discussed, that was Q is equal to I into T. And the second formula was Q is equal to N into E, where Q is the charge. I is the current. Unit of current is ampere and unit of charge is coulomb. N is the number of electrons and E is charge on 1 electron. Its value is equal to 1.6 into 10 to the power minus 19 coulomb. After that we will see units of different terms used. So first term was current I. So unit of current is Ampere, which is represented by the symbol A. Second term was charge. The unit of charge was Coulomb, which was represented by the symbol C. Third term was time. The unit of time was second, which was represented by the symbol S. Now we will discuss conversion of units. First is 1 ampere is equal to 10 to the power 3 milliampere. And 1 milliampere will be equal to 10 to the power minus 3 ampere. Then 1 ampere is equal to 10 to the power 6 microampere. Then 1 microampere is equal to 10 to the power minus 6 ampere. Then we will see what is E. E is equal to 1.6 into 10 to the power minus 19 Coulomb, which is charge on 1 electron. By knowing these formulae and the conversion of units, you may be able to solve these numericals very quickly. So now we are going to solve some numericals. First one is convert. You have to convert 50 milliampere to ampere. Children, we know that 1 milliampere is equal to 10 to the power minus 3 ampere. So therefore, 50 milliampere will be equal to 50 into 10 to the power minus 3 ampere. So if we simplify it further, we will get 5.0 into 10 to the power minus 2 ampere. Or we can write as 0.05 ampere. Then the next question is 15 microampere to ampere. Children, we know that 1 microampere is equal to 10 to the power minus 6 ampere. Therefore, 15 microampere will be equal to 15 into 10 to the power minus 6 ampere. On further simplification, we will get as 1.5 into 10 to the power minus 5 ampere. Next question. Current of 100 ampere flows through a conducting material. How many electrons flow through it in 5 seconds? So what is given to you? You have been given current of 100 ampere. So I am writing here current is represented as I. I is equal to 100 ampere. It flows through a conducting material, number of electrons n they are asking, and time is given to you. Time is given to you, that is 5 seconds. So they are asking you how many electrons. So we can calculate number of electrons by using the formula Q is equal to N into E. But the problem is that we don't know what is Q. So first we have to calculate Q. We can calculate Q by using the formula Q is equal to I into T. So I is given to us. I is equal to 100 ampere and time is equal to 5 seconds. So 100 ampere into 5 seconds will be equal to 500 ampere into second. Children, 1 ampere into second is equal to 1 coulomb. So your answer will be 500 coulomb. So now we have calculated Q. So by using this value of Q, we can calculate the number of electrons. Now we will write the next formula. Q is equal to N into E. Or N will be equal to Q divided by E. We know Q. Q is equal to 500 coulomb. And E is the charge on 1 electron, that will be equal to 1.6 into 10 to the power minus 19 coulomb. Next question. How many electrons constitute 48 coulomb of charge? So they are asking number of electrons. N they are asking. Charge is given to you. Q is equal to 48 coulomb. And we know that E is equal to charge on one electron is equal to 1.6 into 10 to the power minus 19 coulomb. So this is a quite simple question. You have to recall the formula. Formula is Q is equal to N into E. You have to calculate number of electrons. So N will become equal to Q by E. Q is given to us. Q is 48 coulomb. Divided by charge on one electron is 1.6 into 10 to the power minus 19 coulomb. So once we calculate this, we will get the answer 30 into 10 to the power 19. Or we can further simplify it as 3.0 into 10 to the power 20. So 3.0 into 10 to the power 20 electrons will be there in 48 coulomb charge. Now find the amount of current flowing if 600 coulomb charge flows for 10 minutes. So they are asking you amount of current I they are asking. Q is given to you. Q is 600 coulomb. Time is given to you. Time is 10 minutes. But we have to convert that minute into second. So 10 minute, 10 into 60 second. That will be equal to 600 second. Now we can use the formula Q is equal to I into T. Or we have to calculate I, so we can write I is equal to Q by T. Q is 600 coulomb divided by time. Time is also 600 second. The answer will be 1 ampere. The next question. Calculate the amount of charge flowing in a battery if. There are three parts in the question. 40 ampere current flows for 2 minutes. So you have to calculate the amount of charge. So this is a direct question. So we will write the formula Q is equal to I into T. I is given to you. I is equal to 40 ampere. And time is given to you. Time is equal to 2 minutes, but we have to convert that 2 minutes into second. So that will be 2 into 60 is equal to 120 second. Now we can use the formula Q is equal to I into T. So we will substitute the value Q is equal to I into T. I is equal to 40 ampere. Multiplied by time is 120 second. So our answer will be 4800 coulomb. Now the next question, I is equal to 20 microampere. Time was 2 minutes, which in terms of second will be equal to 2 into 60, that will be 220 seconds. So again we will substitute the values in the formula. Q is equal to I into T. I is equal to 20 microampere. So we have to convert 20 microampere into ampere. We know 1 microampere is equal to 10 to the power minus 6 ampere. So 20 microampere will be equal to 20 into 10 to the power minus 6 ampere. So we will write here 20 into 10 to the power minus 6 ampere into 120 seconds. So we will get the answer 2400 into 10 to the power minus 6 coulomb. On further simplification, we will get 2.40 into 10 to the power minus 3 coulomb. So this is our answer. In next question, current is 6 milliampere. So I am writing here I is equal to 6 milliampere. Time is again same. Time is 2 minutes. So that 2 minutes in terms of second will be equal to 2 into 60, that will be equal to 120 seconds. So we can calculate Q by using the formula I into T, but the thing is that here we have to convert milliampere into ampere. We know 1 milliampere is equal to 10 to the power minus 3 ampere. So 6 milliampere will be equal to 6 into 10 to the power minus 3 ampere. So we can substitute the values here. 6 into 10 to the power minus 3 ampere into 120 seconds. On calculating, we will get the answer 720 into 10 to the power minus 3 coulomb. or we can further simplify as 0.720 coulomb. Hey student, thank you so much for watching this video. Don't forget to subscribe my channel and like and share this video with your friends. Thank you so much. Have a nice day.